Hello, fabulous students. Even though I can't be with you today at school since I'm at a training, I didn't want that to stop us from taking some great notes and starting a new topic on scientific notation. So make sure that if you didn't already copy down the essential question, that you do that when the screen goes back up, and we are going to jump in and take some notes. On this screen, you don't need to copy this into your notes, just read along with me. So here's our goal and vocabulary for the day. So today's goal is to be able to write a number in scientific notation when given the decimal form of the number. Just like we did with exponents, we are going to start by making a chart. So this chart does need to go in your notes. It's going to have 3 columns, a scientific notation column, a work column, and a standard form column. Since I'm not there live with you, I know that some of these items might take you a little bit of time to copy. So at any time, feel free to pause the recording, give students a chance to copy the chart down, and then you can click resume on the recording. We're going to move on into our first example. This one, I just want you to watch for a moment, and then we'll go back and we will add this one to our chart. So it asks us to write the following number in decimal form. We just finished exponents, and this is part of exponents because if we look at the last part of the problem, it's telling me that this says 5.75 times 10 to the 4th. So think about what 10 to the 4th power means. It means we're going to multiply 10 by itself 4 times. So that's what this expression is saying. So this is 5.75 times 10 to the 4th power. Now we are going to have a shortcut method for figuring this out. So let me ask you guys a question. I know that I'm not there, so I'm rhetorically asking you a question. On our daily number, whenever we had 10n and we multiplied something by 10, can you think in your head what we had to do to that daily number? So I'll just pick a number. When we multiply by 10, just like in our daily number, we're taking the decimal point and it is moving one place to the right. So my final answer would be 1200. So think for just a second, what would happen now if I'm going to multiply by 10 to the 4th? The first 10 means 1 decimal place. Another 10 would be a 2nd decimal place. This would be a 3rd decimal place, and this would be a 4th decimal place. So we're going to go into our chart now and write down this example. Please call this example 1. This belongs under the scientific notation section. Your problem does not need a box around it. I just needed to create some white space for myself. So go ahead and write down the question, 5.75 times 10 to the 4th. We're going to go over under the work category, and we're going to write 5.75, and this is where we're going to show our work. So to show work, what we're going to do is we are going to multiply by 10 4 times. And when we're multiplying by 10, 10 is the same as moving your decimal place. So if it's times 10 4 times, I have to move my decimal place 4 times. 1, 2, 3, 4. The loops are very important because they are placeholders for us, and inside those placeholders we are going to put zeros. Then we're going to go back and write our final answer with a comma in it. So 57,500. We're going to practice again on the next page, on the next slide. So if it's times 10, we know a multiply by 10 is the same as moving your decimal 1 time. Since it's to the 4th power, I'm moving my decimal 4 times. Please add this to your chart for example 2. Call it A, B, and C. And if you need to pause the recording while students copy the questions down, that's just fine. So once the questions are copied, we're going to go into our chart, and in the middle column, we're going to show our work. So to show your work, you're going to rewrite the decimal portion only. And then we're going to take our decimal point and we are going to move it as many times as the problem is asking us to. So if it's times 10 to the first, I'm going to move it one place to the right. So my standard form would be 74.1. Let's try B. This time I'm going to rewrite my decimal form. And this time it wants me to move my decimal 0 times. That's strange, but why does that make sense? Think about it for just a second. We've been learning about something to the 0 power. In math, anything to the 0 power gets replaced with a 1. So that really says 3.99 times 1. So my standard form would be 3.99. So it makes sense. The 0 means move my decimal 0 times, and the reason it moves 0 times is because 10 to the 0 power means a 1. And last question, the bottom one, go ahead and write out your decimal portion. And this time I'm going to move my decimal 4 times. 1, 2, 3, 4. So this time I do need to add in a 0. And we need to rewrite my answer in standard form. When you have a final answer that's large, make sure you are adding in commas. That way they serve as placeholders so that you can more easily read your number. Now we're moving into example 3. So please take a quick minute, students, to copy down these 3 into your chart. And if you need to pause the recording to give time to do that, go ahead and do that now. So this time what I want you guys to notice is that my exponent is a negative. That's interesting. So what we learned last week with exponents is that when I have a negative, that is the same as me taking that portion of my problem and I have to take its reciprocal, meaning I have to move it to the bottom. So if I move 10 to the negative 2 to the bottom, that's the same as dividing by 10 squared. So think about in math, when we multiplied by 10, we moved our decimal to the right. When I'm dividing by 10, I'm going to move my decimal to the left. So positive exponents move right, negative exponents move left. And we'll do more of an exploration with this tomorrow when I'm back with you guys. So in our work category, let's please write down your decimal version. And I'd like you to take your decimal. We're still moving by tens, so that means we're moving one whole decimal place. But the negative 2 means I'm moving to the left. 1, 2. So add in your decimal, add in your placeholders of a 0. So my standard form is 0.0324. Let's try the second one. The first time we do something, it's always a little different. So let's write out my decimal portion, which is 9.1. This time, please take your decimal. We're still multiplying by 10, which is just a decimal space. And which way are we going? We are going to the left. How many places? 5 places. So negative 5 means left 5. 1, 2, 3, 4, 5. Add your new decimal. Add in all of your zeros. So I get 0.00091. And then our last example, it says 5.6 times 10 to the negative 1. So let's rewrite my decimal portion of my problem. We are going to take our decimal, and since it's a negative 1, we're going to move it one place to the left. So 0.56. My last example for you is I'm going to give you guys a couple different options, and you're going to tell me whether or not these are scientific notation. If you do not think they're scientific notation, I want you to tell me why. So next to example 4, this doesn't have to be part of your chart. This just could be at the bottom of your paper. I want you to have the word scientific notation with a question mark. So we're going to say yes or no. So my first option to you is this. 10.2 times 8 to the 6th power. So think about it. I want you to tell me yes or no and tell me why. Okay, check your answer. The correct answer is no, it's not scientific notation. Just because you see a multiply in the question doesn't make it scientific notation. So it's not scientific notation because it needs to have a times 10 to the something power, right? It can't be an 8. 8's no good. And there's actually one other thing that's wrong with this problem. For scientific notation, the number that's in the very front, let me grab a highlighter here. Let me switch to yellow. The number that's in the very front is not allowed to be a 10. It kind of said it on the first slide, which I know that was a while back, but the number that's at the very, very front has to be between 1 and 10. Has to be between those two. So in other words, they would say less than 10. So in order for that to be true scientific notation, the decimal would actually have to be here, 1.02. Then that would be considered scientific notation if it had a times 10 in it. So there were 2 things wrong with that one. All right, try B and C for me, and then I'll go over answers. So B, 0.45 times 10 to the 6th, and C, 2.109 times 10 to the negative 4. So on your paper, please tell me yes or no to scientific notation, and then let me know what's wrong with it if you say it's a no. If you're not quite ready for my answers yet, go ahead and pause the recording. So B is a no. That's not scientific notation. And the reason being, your decimal is in the wrong place. Your numbers have to be between 1 and 10. Well, 0.45 is less than 10. So in order to be true scientific notation, it would have to say 4.5. The decimal point is always just to the right of the first number. That's where it's supposed to go. And then looking at C, my decimal point is to the right of the first number. There's a times 10 in there, so everything is good. Yes, C is definitely scientific notation. Okay, last part of today. I would like you to try these 5 questions and just pause the recording while students work on these, and then when you're ready, go ahead and start back up the recording. Then the next slide will show you the solutions. So just a couple practice questions just to make sure you have it nailed before you are off to your classwork and your homework. So here are the solutions. Please check your work and fix anything that needs fixing. Again, make sure if it's a big number like the first one that you put your comma in the right place. Right, you definitely want your comma after the 3rd digit. Just check out all 5 of those. Hopefully you did well. Hopefully you are feeling confident. So now you guys are getting ready to jump into your classwork and homework. So I hope that you have a great rest of your day. Work really hard on the classwork. You should finish here. Bring homework home and bring it back for me tomorrow. I will see you guys on Tuesday.